All right, so here we're on chapter 5 on linear inequalities in linear programming. This is section 2 on system of linear inequalities in two variables. All right, so solving systems of linear inequalities graphically. Basically, for a system of linear inequalities, such as, say, x plus y is greater than or equal to 6 and 2x minus y greater than or equal to 0, the solution is going to be the collection of all the ordered pairs of real numbers, x and y, that simultaneously satisfy all the inequalities in the system. So it has to satisfy both of those. And so when we solve each system graphically, we find the graph of all solutions, which is called our solution region, and then we graph each inequality in the system. Now, the intersection of all the graphs in the system is the solution. So going back to this one, what we do is we graph it. And so our first one is going to be everything greater than that. So we have the line going down that's solid because of the greater than or equal to, and it's everything over to the right here. And so then we graph the next piece, and that's going to be this one. And this is going to be everything less than, because when you solve this, this is going to go to the other side. So it's going to be everything y less than or equal to 2x. And so it's going to be everything below. And again, it's going to be a solid line, and so it's going to be everything below. And when you combine them, if we look at it at a graph like this, everything below the blue line, but everything above the red line. So the solution region is over here in the purple region. So it's going to keep going, up here, and it's going to be over here, and it's going to keep going down here, and it's going to be everything over here. And so it's going to be that region. And this point is going to be an intersection point. And so this is going to be kind of the only exact point we know, which is 2, 4. And so that's going to be that. And everything on that line, everything on this line, and everything out in this region out here is going to be the solution. Okay, now it says you can solve it by solving the system of equations. You also can plug it in your calculator and graph and solve it that way. And that's going to be another way to do it is we're going to use our calculators to find these points. All right, so the corner point of a solution region is a point in the solution region that is the intersection of two boundary lines. Now, in example one, we had the point 2, 4, and that's the only point in it. So that's the only corner point. Now, what happens if we have, say, in this case, we have, as we can see, we have three basically inequalities, and then we also have those points where x has to be greater than or equal to 0 and y has to be greater than or equal to 0. So these are our constraints. So this is kind of what we looked at the end of section 1, and we talked about these might show up later. Well, here they're showing up that we're constraining our x's and y's to be greater than or equal to 0. So what that means is we're going to have to basically plot these three lines, make sure they have the proper inequalities on them, and then we also have the constraints here. So that's, and again, that's just showing they have to be in that region of the first quadrant. So again, we're going to graph those points, and when we do that, this is what it's going to look like. So what I've done now is I've actually done it in the calculator, and what I've done is plugged them into y's, and then if you go over here, we can do two things. We can say we want it to be less than, which is showing this way. And so basically you would go down here and we would say it's greater than here, this is less than, or we could have things like a dotted line, even a bigger dotted line or a solid line and a bigger solid line. And that's again greater than or less than. So I went ahead and plotted these with all of them being less than, which is going to be what happens. And then you plug them into the thing and say graph, and that shows you where it's at. And now notice the place where they all intersect is this region here. And so this is going to be kind of where it's at. It's not going to be here. It's not going to be here. It's not going to be out here. Not going to be here. And it's not going to be here. It's only in this region here. And we know it has to be x greater than 0 and y greater than 0. So it has to be within that little bit there. Okay. So let's go back over here. And if we look at it without those shaded regions, then it's going to be kind of here to here to here and that region here. So that's going to be the area that actually is going to work. And so that's what we've kind of shown is just shading only that region. Now what we have to do is we actually have to find those points. And so finding those points is pretty easy on the calculator. So let's go back and do that on our calculator. And when we do that, I'm going to go back in here and I'm going to change these to a line. And so it's going to be easier to do. So let's do a thin line, that'll work. And let's go down here. And so we go down here. And so do a thin line. And let's go down here. Oops, down here. And so now that's what it looks like. And we know it's going to be this region here. We did it with a graph first, and we know it's this region. And now what we need to do is we need to find that point, that point, that point, that point, and we know 0, 0. So what we're going to do is we're going to, first off, we could find this one. And so we could say second trace, and then we can do a value, and when x is equal to 0. Now, we want the black line. We don't care about the blue line. So notice it's showing the blue one. And then it shows the red one. And if we go down one more, here's the black one. So we know the point 0, 10 is going to be one of our points. And so that's something good to know. Now, next thing we could do is we can find the point here. So that's going to be an intersection. So we can do number 5. And we want the intersection between the red line. And so we hit enter. And the black line. So we hit enter. And there's only one place where it intersects. So I'm just going to say, instead of moving over, I'm just going to guess. And now it tells me 5, 8 is that point. Okay. Now I need this point over here, which is the intersection between the blue and red. So I'm going to again hit shift trace 5. Now I'm between blue and red. And I'm just going to hit enter because I don't care. It's only going to be one place. And that intersection is at 9, 4. Okay, so that has given me this one, this one, this one. Now we just have to find this point. And so now we do second trace. And we want the 0. Okay. And which line do we want? Okay, well, we want it on the blue line, so that's good. And so our left bound, we just get that kind of close to 0 for y. And so that's pretty close to 0. And we want on the left side, so we want above for positive. And our right side, we want to be on the other side, the negative. And so that's pretty good. So we hit enter. And that means at 11, 0 is where it crosses. So now if we go back over here, we see that we get 11, 0, the 9, 4, the 5, 8, the 0, 10, and of course our 0, 0, and that gives us all our points. And so that's what you're going to have to do on your calculator when you're solving these. You're going to have to figure out first which region it is. Sometimes just graphing it and then knowing that it's going down, and this one's going down, and this one's going down. Well, you can do that. If you want to do the graph with the highlighting all the areas, that's fine too. I usually just do it with the lines, and then I just kind of, do like they do. I draw arrows this way, draw arrows this way, draw arrows that way, and then I figure out what region it is. And I know that, X and Y both have to be greater than equal to 0, so that puts me into this region here in this case. Okay, and then I use those different pieces. I found the X equals 0, I found the 0 here, and then I found the intersection on those 2 points, and that's how you find all the points for the thing. And so that's going to be your solution because you have your corner points and the shaded region. All right, so again, this is kind of how they're saying to do it. They're saying solve the 2 systems of equations and you get your points, and then the intersection of the blue and the green in their case is not part of the corner point, so we don't have to worry about that one. And so that's kind of how that is. And so solutions of linear inequalities is bounded if it's enclosed within a circle, but if it's not enclosed, it's unbounded. So we've seen both so far. This one is bounded, and our very first one, example 1, if we go back to it, that one is unbounded because it's just going out and out and out. It keeps going forever. And so that one is unbounded. Okay, so that's both of the pieces we've seen so far. And so with the bounded one and the unbounded. All right, so let's stop there and we'll come back for another one.